20-1s. This exciting quadratic function unit continues. All right. Today, with this lesson, it's going to be a lot of little calculations. You're going to have to do some thinking, and yes, you need to learn these processes. So we're going to look at forms of quadratic functions. Now, as a quick background, we have worked, obviously, with the vertex form. But we also have looked, when we talked about the calculator use, we reviewed the idea of the standard or general form of equations. Now, they're both quadratic because they both have that exponent 2. I talked about that with the graphing on calculators. These will both give us quadratics. But we actually used this particular equation last year when we talked lines. But what we did was we had a values of 0. This ax squared wasn't part of it, so we had y equals mx plus b. So we worked with this. And this standard form, general form of an equation, can be used in all kinds of situations. That's why it exists. Y equals ax squared plus bx plus c is a very basic, general, standard form that can suit all kinds of situations. That's why we have it. However, which of these two formulas, equations, are more effective? Well, we've talked about when we have vertex form, it tells us all kinds of stuff to get the quadratic. General form gives us a little bit of information, but only useful if we have a calculator to graph it. So we're going to look this lesson at how we can go from one form to another. This is obviously the beneficial one, but this is one you have to be familiar with because it's a standard general form that can lead us to all kinds of things. So here we go. Let's take a look. Page 12, converting form to form. We're going to start from vertex form to general form, standard form. This is not complicated, hopefully. It's just simplifying the left side. We still want to finish with y equals because that's what our general form is, but we just want to try to simplify this. What does simplifying require? Well, first of all, we want to do the FOIL to get rid of brackets. But I can do the FOIL actually, which will get rid of the exponent first. Then I need to distribute this coefficient and combine like terms. Let's walk through one really quick. Hopefully it shouldn't be too painful. If we take a look at the x minus 3 squared, so many students want to just say, oh, it's x squared and 3 squared is 9, so x squared minus 9. No! Squared tells us to multiply it by itself, which is a FOIL step. First, outer, inner, last, x squared minus 3x plus 9. Simplify those. So our first step leaves us with the 2 times x squared minus 6x plus 9. And don't forget, we still have subtract 11. Always, to go from vertex to general, start with that FOIL step. Now, like number 2 in our process says, we distribute the 2 that's out front. Y equals 2x squared minus 12x plus 18, and we still have the subtract 11. Last step, combine like terms. X squared and x are not like terms because this is an x squared term. This is just an x term. There's my like terms. 2x squared minus 12x plus 7. There's another form. Vertex form we started with can be simplified. Same information, just looks different. Now, algebraically is how you would pretty much have to do these, but how do we know if we're correct? Well, we hope, but also talked about it in the calculator lesson. The calculator, even though it says algebraically, we did the work algebraically, but I have two different equations here. The vertex form, the general form, but they should both represent the same quadratic parabola. So if I punch in both formulas or equations here, 2 bracket x minus 3 bracket squared minus 11. That's our vertex form. We simplified it to 2x squared minus 12x plus 7. That was our standard general form. When I graph this, I have two parabolas here, but it should only show up as one parabola. Well, my settings aren't very good, but we saw when we did that, the first parabola got covered by the second parabola, which is perfect because each form should represent the same thing. So on your calculator, you don't have the colors. You're going to put in two quadratic functions in your y equals, and you're only going to see one graph, which means you've done it correctly. So just going to change my window settings a bit here. We don't need negative 35. We need negative 10 to be consistent. Graph, and there we see it again. In this case, we don't see the bottom, but we do see it's the same graph. So let's try another one. Second one in the booklet. Give it a try. What do you have? F at x is negative bracket x plus 1 squared plus 5. You can try to convert and simplify to the general form. Pause the video, give it a try, see what you come up with. So again, do the FOIL first. Remember, x plus 1 squared means it's x plus 1 times x plus 1 requires FOIL. X squared, 1x, 1 plus 1 is 1. So we finish with negative bracket x squared plus 2x plus 1, and we still have the plus 5. We need to distribute a negative. If it helps you, you could always think of it as a negative 1. Distribute that. Negative x squared minus 2x minus 1 plus 5. Like terms, only like terms are our constants. Negative x squared minus 2x plus 4. There's the general form for our vertex form. Again, real quick, let's check them. We started with the vertex form of a negative bracket x plus 1 squared plus 5. And we finished with what we think is the correct general form, negative x squared minus 2x, whoa, that's not right, minus 2x. That's not working. Let's just start the whole thing over. Negative x squared minus 2x plus 4. That's what we're hoping it is. When I hit graph, I want to see one parabola gets covered by a second parabola. Only see one parabola at the end, which tells me, giddy up, we have the exact same parabola for two different equations. So that's vertex to general form. From there, we now want to go from general form to vertex form. What we're looking at doing, this is tricky. If you practice it, it is manageable. But what's going to happen is the math here isn't as straightforward as vertex to general. we need to do a whole bunch of little things to get a different form. You have to be patient and understand that we're going to do steps and processes that you're going to say, what are we doing that to get to that? Because we need to follow a process that manipulates. We're not just doing math that we're familiar with to simplify. We need to manipulate to go from one form to a more complex form. So it's a process. Now, before we do that, if you take a look at the bottom of page 12, two things we need to take a look at. First thing is factoring out a coefficient. Kind of like GCF factoring, but what you have to be familiar with is we're just factoring out the coefficient on the squared term. Yes, there's an x squared and an x. Technically, we could factor an x out, but we don't want to, and you'll see why in a second. We just want to factor out the coefficient. So we're going to factor out a 5. Divide both of them by 5. That leaves us with x squared plus 7x. I'm not worried about factoring out an x. I just want to factor out the 5. Second one, what would I factor out? I would factor out a 2 so that I can get the x squared by itself. Divide both of them by 2. We get left with x squared. Subtract 3x. Here, we want to factor out a negative 8 so that the t squared gets left by itself. Negative 8 leaves us with t squared. Watch your signs here. Plus 3t. The last one looks a little uglier because of the decimals. What do we want to divide out? We want to get m squared by itself, so we're going to divide out the decimal 7.5. Leaves us with m squared. Factor out, which means I divide by decimal, negative decimal 7.5 there, and I get subtract 8.4m. So this little factor out a coefficient leaves us with something that I'm hoping you're looking at and going, wait a second, that looks familiar. By factoring out just the coefficient, we're left essentially kind of with an a value. A times stuff. We have an a value of 2 times some stuff. We have an a value of negative 8 times some stuff. We now have an a value of negative 0.75 times some stuff. So that's why this factoring out just the coefficient, we're going to be identifying an a value. That's why it's important. Second part at the bottom is factoring perfect squares. So a perfect square, I'll talk about in a second. But to factor this, remember, when you have a simple trinomial, we need two numbers that multiply to the 25 but add to the 10. What is it? It's 5 and 5. Because 5 times 5 is 25, 5 times 5 is positive 10. So if I factored this, it would be x plus 5 times x plus 5. But what's a better way of saying x plus 5 times x plus 5? Well, just saying x plus 5 squared. These are perfect squares because it can factor down to something, x plus 5, times itself. That's the key. They're perfect squares. This second one, x squared plus 12x plus 36, what multiplies to 36 but adds to 12? Well, 6 and 6. So that leaves me with x plus 6 times x plus 6 to be the factored form. But what's the better way to write that? X plus 6 squared. So we again have a perfect square so that we can simplify it to something squared. What multiplies to 9 but adds to negative 6? A little bit thinking. Negative 3, negative 3. Two negatives multiplied give me a positive 9. Two negative 3's added give me a negative 6. So again, perfect square because it's x minus 3 times x minus 3, which is x minus 3 squared. Last one, multiply to 10, add to 20. Well, hopefully you're getting in the groove here and understand it's x plus 10 times x plus 10, because 10 times 10 is 100, 10 plus 10 is 20. Perfect square because it's x plus 10 squared. So why are perfect squares so important? Again, I am oh so hoping you're looking x plus 5 squared, x plus 6 squared, x minus 3 squared, x plus 10 squared. Based on what we've been talking about, what do we have? Wait a second, that's kind of like an x minus p squared. That's why perfect squares are so important. We initially talked about getting that a by factoring out a coefficient. Now we're talking about, hey, we got an x minus p. These are processes that lead us to the vertex form. So let's take a look at page 13. 5 steps, and some of them have multiple steps in them. Please understand, we are going to do things that sort of is like, we have to do this. Well, why are we doing that? Because we need to take this form to the y equals ax minus p squared plus q form, and we got to do some math that makes sense mathematically, but at first you're going, why are we bothering? Because it's important. Here we go. This process is called completing the square, because like I just showed you, we want to end up with an x minus p squared. So we need to complete the square so we can get to that. Step number 1, bracket the x squared and x term. That's all you got to do to start. Bracket those. Second step, factor out the coefficient like we looked at a couple minutes ago. We want to factor out from the x squared. It's going to be a 2. So I'm going to factor out a 2, which leaves me with just an x squared and a negative 6x. Don't forget to finish writing out the entire information. So we've already started off, and look, we have our a value by factoring out from the x squared and the x. Now, here's where we start to do stuff that you're going to go, why are we doing this? So we can finish with what we want. We need to take the coefficient on the x term. This is what I call the magic step, because it's kind of separate by itself. We need to take the coefficient on the x term, and I star it, so I remember it's the magic step. We need to divide it by a 2, and then we're going to square all that. So this is our magic step. The x coefficient divided by 2 squared. And what I do is I'm going to add this value in the brackets. So our magic number gets added into the brackets. So we have 2x squared minus 6x. And what's our new magic value? Negative 6 squared is negative 3. Negative 3 squared is negative 3 times negative 3, which is positive 9. Now, why did we do that? Well, if you look in the brackets now we have a perfect square. X squared minus 6x plus 9. If you do your magic number step correct, what are 2 numbers that multiply to 9 but add to negative 6? Negative 3, negative 3. We have our perfect square. We've completed the square. But before we get to that, here's a tricky step again, but this is mathematically important because we just added this magic number of 9. So this is what we had, and I said, hey, let's put this 9 in. Mathematically, we can't do that. I can't just throw a number into a math equation and say, yeah, let's do it. What the heck? I've changed it. So what we have to do, technically I didn't add a 9. Because that 9 is in brackets with the 2 out front, 2 times the 9, I actually added a value of 18. So by throwing that 9 in, and because it's got a 2 out front, I threw an 18 into this question. I changed the equation by 18. I can't just change an equation. It's not allowed in math. So what I have to do is I have to, and that's why I multiply the number in front of the brackets to see what I've been added to it, but I need to take its opposite or additive inverse and add it to the end of the equation. So if I put an 18 into the question, I changed it, well, you know what I'm going to do? I'm going to take 18 away as well. Because I put 18 in to get what I needed, I'm going to take 18 out so that it still stays as a value of what got added. I added 18 and negative 18. I added nothing then. So we do a whole bunch to say that we've added nothing. Now that's where kids get frustrated. Why do we put a negative 18 so we have nothing? Because we needed to add the 9 to get the right stuff. So that's the reason why we did it. From there, the last thing is to factor the perfect square and combine like terms. So, factor the perfect square. X squared minus 6x plus 9, that's an x minus 3 times x minus 3, which is better written as x minus 3 squared. Oh, x minus p squared. And then combine these like terms. 7 and negative 18 is negative 11. Y equals a times x minus p, subtract or plus q, which in this case is a negative 11. Wow. Kind of goofy steps. But they're goofy steps because we need to finish with a pretty goofy form of what we started with. And the last thing I want to point out is take note that our perfect square trinomial, and we have to finish by saying it's x minus 3, note that what the perfect square factors is the same as our magic number in the brackets. Negative 6 divided by 2, negative 3. So what can we do? Let's check that this is correct. So let's go to our calculator, because I did it algebraically, but I'm just doing a check. We started with 2 brackets. Sorry, that's not what we started with. We started with 2x squared. 2x squared minus 12x plus 7. And we finished with what we think is the correct vertex form. 2 times x minus 3 in brackets all squared. And then we had subtract 11. So we started with the general form. We've come up with a vertex form. If we graph it, bang. Now I can't see all of it, but that's not important because I saw that it's directly on top of itself. Same quadratic parabola from 2 very different looking equations. So that's how you can do a quick check. Here we go. Let's try another one. Lots of practice with this. So number 2, let's walk through it. Bracket the x squared and the x. Boom. Factor out the coefficient so that x squared is by itself. So we need to factor out a negative 3. Watch your signs here. We're dividing by negative 3 because that's what we're factoring out. Leaves us with x squared. 12 divided by negative 3 is a negative 4x is what we get left with, and we still have the subtract 15. Now, step 3 is our magic number. Our magic number, take your x value, negative 4, divide it by 2, and square it. That's the new value that we want to put into the brackets. So we're going to go negative 3, bracket, x squared minus 4x, and our new value here, negative 4 divided by 2 is negative 2. Negative 2 squared is a positive 4. That gets added to the brackets, and we still have the negative 15 on the end. Here now, though, as soon as I add my special number, that's where I remember, wait a second, I've added something. I need to counteract that. I didn't add 4. I added 4 times negative 3, which is a negative 12. By putting this 4 in to give me the right stuff, I put a negative 12 into the equation. I changed it. How do I counteract the negative 12? I add 12 to the end. Because putting this negative 12 in and that positive 12, I've actually added a value of 0, which doesn't change the information, but gives me stuff that I need. Now, I factor my perfect square. I've completed the square, and what number did I use? Oh, negative 4 divided by 2. This should be x minus 2 squared. Negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. So x minus 2 squared is perfect. Combine my like terms at the end. Negative 15 plus 12 is a negative 3. I took my general standard form and created a vertex form, which I can now use a lot more effectively. Because what do I now have? I have a vertex of 2, negative 3. I know that it opens up or opens down because it's negative. I can use this vertex form way more effectively than my standard form. Let's do a quick check. Do we have the right information to get the same parabola? We started with negative 3x squared plus 12x minus 15. And we turned it into a negative 3 bracket x minus 2 squared minus 3. And we cross our fingers, we graph. I can't see a ton of it, but let's just take our window. Let's go y min. Let's go a little lower. And let's graph it now. Boom. Same quadratic parabola, 2 different forms of it in terms of equations. Here we go. Next one, number 3. Let's give it a try. Number 3. Some people stress out because technically there's no number in front to factor out. So we bracket x squared and x. What are we going to factor out? I want x squared to be by itself, so I'm going to factor out a negative 1. Divide by negative 1, divide by negative 1, leaves me with x squared minus 10x, and I still have the subtract 3. We factored out the coefficients. Step 3, magic number. Negative 10, our x term. Divide by 2, and we're going to square it. Negative 1, bracket x squared minus 10x, and now I add my magic number. Negative 10 divided by 2 is negative 5. Negative 5 times negative 5 is plus 25, and I still have my subtract 3. But I added something to change the question. Didn't actually add a 25. Because of that negative 1 out front, I added a negative 25 to this. So because a negative 25 just got thrown in, I need to counteract that and add a positive 25. So even though I added it to get the right stuff, By adding that positive 25, I haven't changed the value because I've added 0 as a value. So I created that 0. Now what do? X squared minus 10x plus 25. Did I complete the square accurately? What do I multiply to get 25, add to get negative 10? Negative 10 divided by 2, it's a negative 5. X minus 5 squared. Combine my like terms. Plus 22. There you go. Technically, that 1's not essential. If you had it, I probably wouldn't mark it wrong. But that's the better form, just with a negative out front. There you go. This is all about practicing. That's what it comes down to. Skip to question 5. Question 5 is a little unique because it's just a P on the end. We can use and follow this process and have variables in our equations. That's okay. This is not junior high math anymore. It's looking at different forms of this. So, same process. Give it a try, pause the video, and then we'll do it together. Here we go. Bracket, x squared and x. Factor out a 2. Leaves us with x squared minus 10x, and I have a plus p on the end. Brackets, factor out a coefficient. Number 3, magic value. Negative 10 divided by 2, and then square it. That needs to be added in the brackets. X squared minus 10x, and that negative 10 divided by 2 is negative 5. Squared is a positive 25 plus p. However, as soon as I add that 25, I've changed it. I need to counteract it. That 25 in the brackets with the 2 out front, I actually added a value of 50. So if 50 went in, I need to counteract by putting a negative 50 as well. 2, bracket, x squared minus 10x plus 25. That factors, look at that, negative 10 divided by 2 is x minus 5 squared. Because negative 5 times negative 5 is positive 25. Negative 5 plus negative 5 is negative 10. And now, can I do anything here? I can't. I just leave it as a p subtract 50. That's fine. Can't combine it. There's no like terms. There's my vertex form. Of course, I couldn't graph this to check. I have to trust I'm doing the right stuff. Here we go with number 6. Number 6 I want to talk about because it starts to get a little ugly because there's some fractions in it. Now, also number 6. This only works if we have standard form. And remember, standard form is y equals ax squared plus bx plus c. So in this case, I need the y to be by itself. Y equals. So I need to move my 5x squared and my 8x to the other side, which gives me, if I move the 5x squared, it's a negative 5x squared. If I move my 8x, it's a negative 8x. So there's now my general standard form. So we go through the process. This one gets a little ugly, but it's manageable if you've understood what we've been doing so far. Bracket, x squared and x. What am I going to factor out? A negative 5. Leaves me with x squared. But if I divide by negative 5, that's a little ugly. Negative 8 divided by negative 5 is a positive 8/5 x. Don't put it as a decimal. Work with it as a fraction. So there's the first 2. I bracketed the x squared, the x. I factored it out. Now the magic number. Little bit uglier because 8/5 needs to divide by 2 and be squared. This fraction work at this point shouldn't be overly complicated. Dividing by 2, remember, is the same as multiplying by the reciprocal. So we get 8/10. And what do we have to do with that 8/10? We need to square it, which is 64 hundredths. Now, instead of going 8/10 though, really, let's work with smaller values. 8/10 is the same as 4/5 squared, which could be reduced to 16/25. So yeah, it's a little bit of fraction knowledge, which goes back to junior high, and you should at this point be comfortable with it. So a little bit uglier magic number because of fractions, but should still be manageable. So I need to add 8/5 divided by 2 is 4/5. Square it. I need to add a 16/25. I added a 16/25. There's no extra value on right now, but that doesn't mean I don't have to counteract. 16/25 times -5. 16/25 times the -5. What actually got added? Again, 16/25 got added, but when I multiply it by the -5, it's going to be negative. We should be comfortable with fractions. To simplify, that's a 1 and a 5. 16/5 negative. So we put in a -16/5. To counteract, I need to add a 16/5. So the fraction makes it a little trickier, but it's all basic fraction calculations. Y equals -5. I now complete the square and I factor it. Well, what two things multiply to 16/25 and add to 8/5? That's a little ugly. But remember, our difference or our perfect square factoring, there's the value. What was 8/5 divided by 2? 4/5. So it just becomes x plus 4/5 squared. This would be ugly to do on our own, but that magic value, what's in the brackets, goes into our factored form. And I still have the plus 16/5. So with fractions, yeah, it looks uglier, it's trickier, but it's still manageable, or should be. Here we go, last example. General, standard form to vertex form. Give it a try with the fractions, and then we can do it together. One more time. X squared and x. Factor out a -1/2. Leaves us with x squared. Quick calculation. We need to, if we're factoring out a -1/2, divide by -1/2. 10 divided by a -1/2. We don't divide fractions. We multiply by the reciprocal. This should be a quick, easy chicken scratch calculation somewhere. It's the same as having a -20x minus 3. Know your basic fraction work. At that point, magic number. Magic number's not too tough. -20 divided by 2, and we need to square it. So we have -1/2 x minus 20x, -10 squared, positive 100 minus 3. But we put in that 100, but with the -1/2 out front, we've actually added a value of -50. 100 times a -1/2, a -50 got added, so we counteract by adding 50 here. -1/2, x, 20 divided by 2, negative, is a -10 squared plus 47. There's our vertex form for this situation. Doing this work with fractions, yes, it's trickier, but you have to be able to accomplish it. So your assignment for this textbook, page 192, number 2, 3, 4, 6, ABC in each section. So 2 ABC, 3 ABC, 4 ABC, 6 ABC. Practice is essential. The worksheet that you should have that talks standard to vertex form. In that case, taking all of these from standard to vertex form, a separate sheet of paper to show your steps and be neat. You can omit those 4, 1, 5, 8, and 9. Everything else should be manageable. So, vertex form is your friend. If you don't have it, you need to get to it. That's what this is all about. The only way to get better is practice. Have fun with it.